All right, so let's talk about conversions. You've heard me talk about conversions in the past, but we're going to talk about specifically molar mass. One such example I give quite a few to quite a few of my students is methane. A common example, pretty straightforward. Water is also a pretty good example, but let's look at methane. So we have CH4, right? When I'm looking at CH4, I have one carbon. We're going to use nice round numbers, which will give me 12 grams per mole. I have hydrogen is 1 gram per mole. I have four of them. Therefore, when I add all these, I should get 16 grams per mole. Okay. If I have water, I know I have one hydrogen, two hydrogens, one oxygen, and essentially I have, so the 2 times 1 gram per mole, and we have basically, if we round up, 16 grams per mole, which should leave me with 18 grams per mole for water. Okay, but let's say we had a more complex example, and the example was such as, um, I would say, how many hydrogen molecules are there in 5 grams of CH4? Well, before we can even do anything with this, let me introduce you to Avogadros number. Okay, Avogadros number is essentially 1 mole of any particular substance, in this case, or element, is equal to 6.022 times 10 to the 23rd atoms slash molecules. Okay, so how many hydrogen molecules are there in 5 grams of methane? So first and foremost, we need to know what the molar mass of CH4 is. We did that before, which basically is going to be 16 grams per mole is going to be for methane or CH4. Due to the fact that I know I need to convert the moles because I'm trying to get the molecules, I could take 5 grams of CH4, multiply it by 16 grams of CH4 and 1 mole of CH4. Keep in mind the grams at the bottom, this is at the top, that we can cross those out. It should give me 0.3 moles of CH4. Due to the fact that I need to go to moles to molecules, the way I can set that up is I can say I have 0.3 moles of CH4. Avogadro's number is 6.22 times 10 to the 23. If I go ahead and put that at the top or bottom, well, we want to make sure it's at the top because that's what we're trying to convert it to. Now, this looks like it could be correct, right? Unfortunately, it's not. What I found out was of methane, right? However, what I needed was of hydrogen. So the question is, what is the ratio of methane to hydrogen? For every 1 methane, there are 4 hydrogen. Therefore, we need to backtrack a little bit, okay? Due to the fact that I have 4 of these, I need to multiply the 0.3 moles of this times 4. So what is that going to be? It's going to be 1.2. So it's technically 1.2 moles of hydrogen. So we don't want this method. We want to use the moles of that. So it's going to be 1.2 moles of hydrogen times, we need now the Avogadros here in this instance. So we take 0.022 times 10 to the 23 molecules over 1 mole. Moles cross out. Therefore, my answer should be essentially this guy. 1 second. Should be 7.23 roughly times 10 to the 23rd molecules of hydrogen. And that would be my answer.